Hi everyone, Pre-Calculus 2-1 Power and Radical Functions. We're gonna talk about these topics. Okay, when you deal with a polynomial or monomial, we can talk about degree and leading coefficient. And you should be able to sketch the graph for end point. No, for both ends, left hand and right hand. Okay, degree means highest power of x. If degree is even, both ends go to same direction. If degree is odd, both ends go opposite direction. So if let's say highest power is even, if one side goes up, the other side goes up. If one side goes down, the other side goes down as well, same direction. Let's say degree is odd power. Then one side goes up, the other side goes down. One side goes down, the other side goes up, opposite direction. Leading coefficient, highest power of x, number in front of x, we call that as a coefficient. If a leading coefficient is positive, we say right hand goes up. If leading coefficient is negative, right hand goes down. It can only tell you what happened to the right hand. Okay? So if leading coefficient is positive, you know right hand goes up. If leading coefficient is negative, right hand gotta go down. Same thing. If leading coefficient positive, you know what happened to the right hand side goes up. If leading coefficient is negative, what happens to the right hand side goes down. So you do need to memorize this when I ask you to get those questions without graphing calculator. That's when you need to do this. Okay. So graph and analyze f of x equal to 1 over 2 x to the 6th power. Okay, so this is the part you could sketch it without using graphing calculator. Highest power of x, 6. Well, there's only one x, by the way. Highest power of x is 6. 6 is a degree. Degree is even or odd? 6 is even. So we got even, both ends the same direction. Okay, so either they go up together or they will go down together. Now, leading coefficient. Leading coefficient is a number in front of highest power of x, which is 1/2. 1/2 is leading coefficient, positive or negative. 1/2 is positive. So I can tell you 1/2 is positive, so you gotta go up on the right. What's gonna happen to on the left? Do you remember? Even power is the same direction, so left hand gotta go up too. Okay? You might say there might be something different between, but if there's just only one term, usually you just get like something like this. Okay, there could be more than one term here. Then it's not the case. There might be some up and down between. Okay, so the exact graph, unless it's one term like this, it will be a variation. It could be something like this, but if it's only one term, you will have this, and that's the rough sketch of it. Okay, if you graph it using graphing calculator, the exact graph would look something like this. Okay, so knowing that, I can ask you, describe the domain, range, intercept, and end the behavior, continuity, and where it's increasing and decreasing. So given this graph, let's say you graphed it using graphing calculator. Let's answer all those. Domain. Okay, domain means all possible x value, meaning x-axis is this. How far to the left graph covers. 2, how far to the right graph covers. That's what I mean by domain. If you look at this graph, it keeps going up, but also it keeps going to the left as well forever. Keeps going up, but it also keeps going right side too. It keeps expanding forever to the left. It covers everywhere. So domain is all real number. Minus infinity to the infinity covers everywhere. That's a domain. Range means how low to how high. So if you look at this sketch, the lowest you can reach is 0 here. 0 through forever, which is 0, comma, infinity. And 0, we have nice solid curve here. So it should be bracket because 0 is included. That's a range. Intercept. We have x-intercept right here. It's passing through origin here. You might say, well, how am I supposed to know that? If you're trying to find x-intercept, you plug it in 0 for y. So that's the same as y equal to 1 over 6, 1 over 2 x to the 6th power. If you're trying to find x-intercept, algebraically, you plug in y as 0. 0 equal to 1 over 2 x to the 6th power. We're solving for x. Multiply by 2, both sides. So multiply by 2, so 2 times 1 over 2 disappears. Take a sixth root both sides. X equal to 0. That's the answer. Okay, if you can see that from the graph, it's not necessary for you to do it. Okay, so if you look at it, it's passing at 0 right here and moving away. If you can verify that from the graph, all this work is not necessary. So x-intercept is 0. So if I magnify this portion, it's this. This is what's happening like this. If I magnify that portion, so you should know it's passing through, actually touch and turn around an x-axis, also passing through y-axis here. So x-intercept 0, y-intercept also 0 because it's passing through 0. Now, and the behavior. So we could have tell left hand goes up, right hand goes up. Okay? So this is a fancy way of saying left hand, limit of f of x as x approaches to minus infinity. That's left. As you go to the left, what happened to the y? Increasing, increasing, increasing. So you need to say that as positive infinity. As you go to the right, that's a fancy way of saying moving to the right. Limit of f of x as x approaches infinity. What happened to the y? Y is approaching to positive infinity. So that's ND behavior. Continuous for all real number. It's connected everywhere. So all real number continues. Decreasing. Do you remember? As you trace to the graph to the right, as you move to the right, what happened to the y value? Decrease, 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 decrease up to here. It's decreasing. All left-hand side, it's decreasing. So minus infinity to 0, decreasing. Where does it start increasing? Right here. Start increasing right here, increase, increase. Y value keeps going up, 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 up. From here through right-hand side. So 0 through infinity is increasing. Do you remember? Increasing, decreasing answer, always a parenthesis. You never use a bracket for increasing, decreasing, constant interval. Okay, graph and analyze this equation. Again, you can put it into the graphing calculator and look at it, but it's possible for me to do it without graphing calculator. Then you need to know this. Okay, excuse me. Leading coefficient. Number in front of the highest power of x is -1. Leading coefficient is -1, so that tells me right hand gotta go down. Okay. The degree, if you look at the power, is 5, which is odd power. So that tells me both ends opposite direction. We already figured it out. Right hand goes down. What happens to the left hand? It gotta go opposite direction. It gotta go up. Okay. Since it's only monomial, only one term, that's gonna be connected nicely, something like this. So that will be the rough sketch of it. So if you use your graphing calculator, it's gonna be exact graph will be something like this. Okay. And we are describing all those property. Domain, again, keeps going to the left forever, keeps going to the right forever. It covers everywhere, all real number, minus infinity to infinity. Range, keeps going down forever, keeps going up forever. Up and down covers everywhere, all real number 2, minus infinity to infinity. Intercept, it passes right here. X-intercept, 0. Y-intercept, also 0. Both of them is passing right here. So it's, if you magnify that portion, it look like passing like this. That's what's going on. X-intercept is 0, Y-intercept is also 0. Okay, as you go to the left, and the behavior, as you go to the left, what happened to the Y? Increase, positive infinity. As you go to the left, positive infinity increases. As you go to the right, what happened to the Y? Y value decreases. As you go to the right, limit of f of x as x approaches infinity, what happened to the Y? Minus infinity, going down. It's connected everywhere, continuous everywhere, continuous for all your number. As you move to the right, decreasing, 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 decreasing. This is decreasing everywhere. It never increases. It never goes constant. Decreasing everywhere. Decreasing minus infinity to positive infinity. Okay? Okay. Graph analyze f of x equal to 2 to the 2x to the minus 4th power. Okay. Now you cannot use this anymore. This is for positive integer. So this one, you just put that into the graphing calculator. Graph it using graphing calculator. It would look something like this. Okay? Then you can answer, I ask you what is the domain. So if you look at it, you can see there is gap. It's not connected. The left curve, right curve are not connected to each other. So it keeps going to keep going up, but they will never touch each other. So there's nothing going on at x equal to 0. What does that mean? Domain is x cannot equal to 0. Domain should be x cannot equal to 0. Well, your Alex is asking interval notation. So cannot be 0. So 0 is a whole, empty whole. That means everything else is okay. So you can cover everything on the left. You can cover everything on the right. That's all good, except you cannot have 0. So interval notation, left interval here, minus infinity to 0, minus infinity to 0, union with 0 through forever, 0 through infinity. That will be your domain. Everything but 0. Range, lowest you can hit is 0 and higher, so 0 through infinity. One thing you have to be careful, this keeps approaching to 0. It will never touch the 0. There's a horizontal asymptote here. So it gets closer, never touches it. So that's why 0 does not have bracket. 0 parenthesis, higher forever, infinity. There's no intercept here. X-intercept, the graph is not going to touch x-axis. Y-axis, graph is not going to touch y-axis either. What happened to the left hand? As you keep going to the left, what happened to the y value? It approaches to 0. So you might say, well, how am I supposed to know that? You can use your graphing calculator, okay, and plug in x value as a very, very, very small number. Like try x value as like minus 10,000. Your calculator will give you y value as a 0 or 0.0000, which is almost 0. So it's approaching to 0. So left hand, if you go left, y approach to 0. What happened to the right hand? If you keep going to the right, y value also approach to 0. So left hand, right hand, both end the behavior approach to 0. Infinite discontinuity at x equal to 0. Yeah, it's not connected here x equal to 0, and this kind of discontinuity is infinite discontinuity. Increasing. As you go to the right, increase, wider increasing. So left hand side is all increasing, minus infinity to 0, increasing. Right hand side, as you go to the right, it's all decreasing. 0 through infinity is all. So this is increasing, this is decreasing. Okay, so 0 comma infinity is decreasing. Okay, you should do graph this using calculator and try to do the analysis. Pause it, please try.